Just take a look around you for a second. The building you're in, the car driving down the street, maybe even the chair you're sitting on. Chances are they all share one critical ingredient. We're talking about steel, the unseen giant that literally forms the backbone of our modern world. It's so fundamental that we barely even notice it, but honestly, without it, our civilization would look completely different.
I mean, really think about it. It's in the massive beams holding up skyscrapers, the frame of your car, and it's also in the fork you eat with and the paperclip on your desk. Steel is just everywhere. It's the silent partner in pretty much everything we do.
So we see it and use it every single day, but what is this stuff actually? How does a pile of rock dug out of the earth get transformed into the incredibly precise material that defines our age? Well, let's break it down.
You know, for all its strength and complexity, it all starts with a recipe that's surprisingly simple. It really just boils down to a couple of key ingredients.
At its heart, steel is basically just iron with a little bit of carbon mixed in. Now, pure iron on its own, it's actually pretty soft, but you add that tiny bit of carbon and everything changes. It's one of the most game-changing additions in the entire history of materials.
And when we say a small amount, we mean it. For most types of steel, the carbon content is less than 2.1%. That tiny little fraction is the secret sauce that transforms soft iron into the strong, versatile material we all rely on. It's just an amazing example of how a tiny change can have a massive impact.
And just like a chef adds spices to a dish, metallurgists, the experts who study metals, add other elements to the recipe to give steel all sorts of special properties. You want steel that doesn't rust? Add some chromium. Need it to be incredibly tough and not shatter? Mix in some nickel. Each of these alloying elements fine-tunes the steel for a very specific job.
Okay, so we've got the recipe. Now, how do we actually cook it up? Well, the journey from raw iron ore to a finished steel beam is this dramatic process of fire, chemistry, and just immense power.
All right, here's the 30,000-foot view. It all starts in a mine with iron ore. That ore gets cooked in a giant blast furnace with something called coke, which is a high-carbon fuel made from coal to basically strip away all the oxygen. What you get is this crude, high-carbon molten iron, which is called pig iron. Now, this stuff is still pretty brittle, so the last, most critical step is to refine it, burn away the extra carbon and other impurities to get pure, strong steel.
And that refining step? Today, it happens in one of two main ways. First, you've got the basic oxygen furnace, or both. This thing takes that molten pig iron and blasts it with pure oxygen to burn everything off. It's super powerful and great for making huge amounts of steel. The other path is the electric arc furnace, or EAF, which is basically a giant recycling machine. It uses these insane electrical arcs to melt down old scrap steel, which makes it way more energy efficient. But wait, it doesn't stop there. After that first round of refining, the molten steel goes through this crucial fine-tuning stage. Think of it like quality control. They adjust the temperature, add those precise alloying elements we talked about, and they even use a vacuum to suck out unwanted gases that could create tiny flaws in the final product.
So once the chemistry is absolutely perfect, the liquid steel has to become a solid, right? It gets poured into a cooling mold in a process called continuous casting. This solidifies it into these huge, semi-finished shapes, like slabs or billets, that are now ready to be rolled into their final form, whatever that may be.
And this right here is where steel's true genius really comes out. See, it's not just one thing, it's a whole family of materials, and each one is perfectly tailored for a specific job.
By just tweaking that recipe a little bit, you get completely different materials. Add enough chromium, and boom, you get stainless steel, which creates this invisible, self-healing layer that keeps your kitchen sink from rusting. Add other elements like tungsten, and you get tool steel that's so incredibly hard it can literally cut and shape other metals. This adaptability is what makes steel so totally indispensable.
So where does all this amazing specialized steel actually end up? Well, the biggest consumers, by a long shot, are construction and transportation. Our entire modern infrastructure, from skyscrapers and bridges to cars, ships, and trains, is built on a foundation of steel. It's truly the engine that powers the global economy.
Now, beyond just the chemical recipe, steel has another superpower. By heating it and cooling it in very specific ways, a process called heat treatment, you can fundamentally change its internal crystal structure. You can take the exact same piece of steel and make it incredibly hard, or you can make it soft and easy to shape. It's almost like magic, this versatility.
So steel has clearly built our past and our present.
But the traditional way of making it comes with a major environmental cost. And that brings us to the biggest challenge and the biggest opportunity for the future of this industry.
Okay, here's the core of the problem. That very first step we talked about, the blast furnace that turns iron ore into pig iron, it relies on burning massive amounts of coke made from coal. That process is incredibly energy intensive and releases huge amounts of carbon dioxide. In fact, it makes the steel industry one of the largest emitters in the world and a major focus for climate action.
But steel has a huge ace up its sleeve in the race for sustainability. It's one of the most recycled materials on the entire planet. Unlike plastic or paper, steel can be melted down and reformed over and over and over again without ever losing its fundamental properties. This perfectly circular life cycle is absolutely key to its future.
And the industry is pushing hard on innovation. Researchers are developing ways to make iron using hydrogen instead of coke, and the only byproduct is water. They're working on capturing carbon right at the source and creating stronger, lighter steels so we can do more with less material. This isn't science fiction. This is the work being done right now to create what they call green steel.
Which kind of leaves us with this one big question. Steel gave us skyscrapers, railways, the entire industrial revolution. It's a material of immense strength in history. The great challenge now, and the great opportunity, is whether this exact same material can be reinvented to build a cleaner, more sustainable world for all of us.